So I hope you can see this. I'm sorry it's a little bit small. But to try and fit the formulae and the question with the diagram and the questions on the screen is a little bit of a challenge for me. I'll just see if I can make these questions just slightly bigger, slightly bigger without anything. Yeah, you see now the mark allocation has disappeared off, but all right, never mind. We'll just
My
have
side, I can
to.
see
Can
everything.
you see everything okay? All
Yes.
right. So I don't know where on earth I'm going to write, but anyway, we'll deal with that. We'll deal with that now. Okay. If you guys have got a formula sheet to hand, then that would obviously be very useful because then it means I can get rid of the formulae. I think by now we pretty much know all our formula really well. But I obviously will explain which formula we're using in which situation, although you should probably know that by now too. Okay, so let's have a look at question 2. They've said to us in the diagram below, we have 4 points on the Cartesian plane. So there's A with the coordinates 3 and 7. That is the vertex of triangle ABC. The other vertices are B with coordinates 1 and -6, and C with coordinates -3 and 4. AC is extended to intersect the x-axis at D. And M is the midpoint of BC. M is down here in the third quadrant. It is the midpoint of BC. And then ADO is theta. So we can see theta over there for ourselves as well. And sorry, this is theta over here, ADO. And the inclination of BC is angle alpha. All right, so there's 2 angles on the diagram as well. So the first couple of questions are quite simple, and then it sort of builds to a nice difficult question, question 2.6, which we're going to have a look at in due course. All right, so the first question, 2.1, asks us to determine the coordinates of the midpoint of M, the coordinates of M, the midpoint of BC. So that's fairly straightforward. All we would need to do here, of course, is just sub into midpoint formula. All right, so in 2.1, the coordinates at M, I'm going to sub in the coordinates from C and D. So it would be -3 + 1 over 2 for the X coordinate at M, and 4 + -6 over 2 for the Y coordinate at M. So that means at M, the coordinates are -1, and over here I would be getting -1 as well. All right, easy enough. 1 mark for subbing into midpoint formula, 1 mark on the answer. Now, question 2.2 uses the word hence. Hence determine the equation of a circle having center M and passing through B and C in the form, and we've got to give our answer in the form x minus a squared plus y minus b squared equals r squared. All right, so what should we do now? What should we do, Matrix? How are we going to find the equation of this circle? What should I do? And what does the word hence mean? I think we've discussed this before. If the question says hence, what do I have to do? I have to use my previous answer. Okay, so a couple of people, Chad, you said I need to substitute. Let me just see who else said that. Letu also said I need to substitute. So what am I substituting and where? What needs to go where, guys? Okay, so I've got to sub point M's coordinates into the equation, but where? Where do I sub them in? Do I sub them in place of X, Y, A, B, R? Where do the coordinates from M go? Okay, so the coordinates for M, for A and B respectively, says Pinga, yes. In place of A and B, good, well done. All right, lovely. So in other words, I'm going to end up with X plus 1 squared plus Y plus 1 squared is equal to R squared. Okay, so I've subbed in the coordinates of M in the place of A and B, and this is what I have. Okay, now I have to solve for R squared. Okay, good. So Mary Liz, for R, use either B or C. Good, well done. Some P with a subcoordinate into A and B. Well done, that's perfect. So now I can choose. Either I can work with coordinates at C or the coordinates of B, sub those in and solve for R squared. So let's say I decide I'm going to go with B. The X coordinate at B is 1. The Y coordinate is -6. And I'm able to calculate R squared from that. What are you guys getting for R squared? Just want to see what your answers are. Me too, Mary Lynn. Chad, my answer was different to yours. What's anybody else getting? Me too, Boychul. Me too. Simply with me as well. I'm also getting 29. Yeah, there we go. So now I can put the equation of the circle together. This gives me X plus 1 squared plus Y plus 1 squared is equal to 29. And I'm not going to take the square root of 29 because remember, when I write the equation of my circle on the right-hand side, I want R squared. I don't want R. Okay, no problem, Chad. It's fine. Okay, so that's out of 4 marks. So there would have to be a mark for subbing in A and B correctly. There would have to be a mark for subbing in the other point, calculating R squared, and then the equation of our circle. All right, cool beans. Now let's go on to question 2.3. I'm going to pop that in over there. And I was trying to emphasize again the other night, make sure you label your questions clearly and correctly. Okay, in finals, they're not going to assume just because there's an answer there that it belongs to question 2.1 or 2.2. You have to label your questions correctly. The order in which you work is unimportant. You can do question 10 first if you want to, and question 3 last, or whatever. You don't have to work in the order of the paper, but make sure that everything is labeled correctly. That's more really paper 1. Paper 2, you'd be writing in an answer book, but you'd still need to be able to label your questions. Okay, all right. So question 2.3, given that the gradient of BC is -5/2, calculate the value of alpha. Now, this is a question that a lot of matric students end up getting wrong because the way in which they've set it out is incorrect. Okay, first of all, what formula are we using? And then we'll talk about the correct way to set things out. Okay, Chad, thank you for your answer. You are correct. I just want to check that the way we've set it out is perfect. That's fine. All right, so what formula are we using for this one, guys? What formula? Don't be shy, matrix. There we go. All right, so tan theta equals m. Good. All right, so we would say tan theta equals -5/2. All right, and this is the part that you need to set it out correctly. Okay. That's it, Pinga, quite correct. Okay, you got the same answer as Chad. So here, first of all, you are calculating a reference angle or a key angle. I like to call it a PAA. It is not theta, okay, because theta needs to be an obtuse angle. All right, so we would go shift tan. We'd put in our ratio. It must be positive. And that gives us a reference angle of 68,20. Whoopsie, 60. 68,20. All right. And now, sorry, I made a mistake there as well. This is something else, sorry, and I've just done it and I've just realized that I've done it. I've made a mistake there as well. If I write theta here, I'm wrong. Remember, I've got two different angles on my diagram. So I must write tan alpha equals -5/2, not tan theta. Okay, because I'm working with angle alpha. So just make sure that you don't make that mistake as well. So that means that alpha is going to be equal to 180 minus 68,20. And we would get the answers that Chad and Pinga have offered us, which is 111,80 degrees, like so. Okay, so remember, when the gradient of your line is negative and you are calculating an angle of inclination, you first have to calculate a reference angle, which must be subtracted from 180. Okay, so that you have an obtuse angle and not an acute one. Okay, because the gradient is negative. Yes, layer 2, it is absolutely fine to set it out like that as well. Not a problem at all. Okay, so 2 marks. I think it would be for that and for that. Let's go on and calculate the size of theta. That should be fairly easy for us. What are you guys getting for theta? So for tan theta, we're going to use the gradient of line AC. Do we have the gradient of AC? No, that's not a piece of information we've got, so we'd have to calculate it. So we would say 7 minus 4 over 3 plus 3. So therefore, tan theta would be equal to 3 over 6. So that would be 1 over 2. Okay, so because our ratio is positive, our angle of inclination in this case is an acute angle. So our reference angle is theta in this case. So therefore we can go shift tan, put in the half, and work out the size of angle theta. You should be getting, no, Mary Lynn, it doesn't. So if you want to say 4 minus 7 over -3 minus 3, you'll get the same answer. Okay, what's important is that if you started with coordinate A as your first y coordinate at the top, you've got to start with the x coordinate of A at the bottom. Okay, so if you start with the y coordinate of C at the top, you've got to start with the x coordinate of C at the bottom. The other thing that I must also just mention to you at this point, guys, before we continue any further, is that when it comes to gradient formula, they are very, very picky, and I'm sure your teachers have reminded you about this at school as well. If you do change in x over change in y, you get no marks. Okay, so don't mess up your formulae. Okay, remember, for gradient, it must be change in y over change in x. So if you do sub into gradient formula and you've got the change in x at the top and the change in y at the bottom, you won't even get any marks for subbing in. Okay, so just be aware of that when you work with gradient formula. Okay, so I'm getting theta to be 26,57 degrees. Do you guys agree? Are you getting the same answers? Jamie says, isn't it 2 over 3? So 7 minus 4 is 3. And at the bottom, we've got 3 plus 3, which is 6. Am I correct? Just double check me, everybody. Oh, you made a mistake. Okay. No, it's just I made mistake. I make mistakes all the time, Jamie. So it could just as well be me as well. Okay. All right, where were we? All right, so we've done 2.4. Now we're going to do 2.5, hence or otherwise. So in other words, using theta, but if there's another method, you're allowed to do that as well. Calculate the size of angle DCB, giving a necessary reason. Okay, so DCB is this angle over here where the little orange dot is. Sihle, then essentially you've not rounded off correctly to 2 decimal places if you write 26,56. Okay, so you'll be out a little bit there. All right, I think they would probably still mark it correct. They don't mark you down on rounding. The only place in finals where you get marked down on rounding is in paper 1, when you have to use the quadratic formula to solve for x in the first question. Okay, but we want to get it correct. Okay, Aisha, if I've pronounced your name correctly, what is it about 2.4 that you don't understand? Perhaps, Yolanda, you can reach out to Aisha and just find out what they're struggling to understand in question 2.4. Yolanda, sorry guys, just 1 second. Yolanda, are you there? Oh, I don't know where Yolanda's gone. Okay. um,
Yeah, I'm here.
Oh, you here, you here, you here. Oh,
Responding,
sorry.
yes.
Sorry,
Yeah.
that's fine. I was just asking if you could just reach out to Aisha. They're just struggling
Yes.
to understand question 2.4. If you could just assist
Yes.
Aisha there quickly,
I'll
please.
do that.
Thank you so much. Okay, so now going back to question 2.5, Mary Lynn, you've said if M is the center of the circle, isn't C equal to 90 degrees? No, not necessarily, because we don't know if C is a tangent to the circle at that point. Let's see what Letu is saying. Would you call the angle next to alpha? Oh, okay, you're doing angle, sum, and triangle. That's absolutely fine. Okay, so Letu has DM'd me and said, if we calculate the size of this angle over here, right, we can do that using adjacent angles on a straight line, and then we can use the sum of the angles in a triangle in order to calculate the little orange angle that we want. That's absolutely fine there too. That's not a problem at all. There's one other way that you can do this question as well. Philosians giving an answer. And the other way that you can do this particular question, guys, is to use exterior angle of triangle. So the x-axis is one of the sides of the triangle. There are the other 2 sides. So angle alpha will be equal to the sum of theta and DCB. Okay, so either you can do it the way that Letu suggested, or you can do it the way that I have suggested as well. Because we don't actually have a name for this point over here, it's going to be a little bit more difficult to do that, because you might have to write on your diagram and give that point a name so that you can explain which angle you're trying to calculate. If you do an exterior angle of a triangle, then you don't actually have to do that, which is fine. You can, Tsegofat. So just give me 1 second. I just want to do the solution to this question, and then you are more than welcome to ask me a question. All right. So what I would say here is that theta plus DCB is equal to alpha because of exterior angle of triangle. And that means that theta was 26,57 plus DCB is equal to alpha. I'm just subbing that in. That was 111,80. And then that means that DCB is going to be equal to 0.8 minus our 26.57, and we get 85,23. Someone did say that in the chat just now. Let me just go back and see who it was. Oh, it was Voloshin. Okay, there we go. All right, so that was out of 2 marks. So here, statement reason, and then our answer. Okay, Tsegofatso, do you want to unmute and ask your question? You're welcome. Tsegofatso? Okay, where, Tsegofatso? I can't see your question in
Yeah, I'm also scrolling
the
up.
comments.
Yeah.
Yeah.
Can I ask something completely off topic? If I want to get good at maths, I know it's a practice every day. How are you especially in
How do
holidays
you?
time? That's
Oh,
your
okay. So that
question.
is your question. Oh, okay. Sorry, Tsegofatso. I misunderstood you there. How do you especially in the holidays time? I'm afraid, maybe you can just reach out to Tsegofatso and just ask them if they could just explain what they mean by that.
Yes.
I
Okay,
don't
so
quite
we can talk.
understand what they're asking.
I will talk
Oh,
to
that's
Tsegofatso
okay, Mosey.
privately.
Okay, please. Thank you. Okay, thank you. All right. Let's go on to question 2.6. Thanks, Mosey, for helping. I didn't understand what Tsegofatso was saying. I'm sorry. Okay, so question 2.6. So now they say to us, if G with coordinates S and T is a point such that T is equal to 2S plus 1 and GC is equal to root 17, calculate 2 possible values for S and T. How do you practice? How do you effectively practice? Okay, all right. So that's what you were asking. All right. So at this stage, Tsegofatso, you should be working on final papers. All right. What you should do is before you embark on the paper is go through the notes that your teacher has taught you in class and the rules and the methods that you need for a particular section. Make sure that you know the methods, make sure that you know the rules that you need to use in a particular section, and then go and practice exam questions. There is a whole host of papers online. The department post all their papers, their supplementary papers and their final papers on the department website. All the memos are there as well. So if you've got a connection to the internet, you've got a connection to all those papers. All the memos are there. They've all got different solutions for particular questions. Go and practice the questions. You've got to make sure as I say, you've learned the rules and the methods first, then go and practice the questions. All right. And you should be spending, I mean, you guys, I'm sure most of you are probably coming up for study leave now. You should be spending, the same amount of time that you would spend at school studying, and then still in the afternoon and into the evening. So it's a lot of work. It's tough, but you know, it's completely in your hands now to make sure that you matriculate with the best possible results. Okay, if I was you, if it was me, I would make sure that in the holidays I get up early in the morning, have a good breakfast, and then I would start studying, and I would study for 3 hours and take half an hour break and study for another 3 hours and take a half an hour break. And then I would probably come back and then do another probably 2 hours of study again in the evening. Yeah, so I would focus on final papers. If you do I mean, trials papers should mirror the final papers anyway, but don't do June, don't do March. You could do supplementary papers as well. Okay, so yeah. Okay, Tsagofatso.
And if you join the camp, Profazo, you're gonna get more tips and checks.
Yeah, absolutely, and more papers. Yeah, so please do join us if you can. All right, so let's just get back to this question. We are talking about GC. So line GC is essentially over here. It doesn't matter that it's not drawn. They've told us that its length is root 17, and they want us to determine two different possible values for S and T. So how would we do this? It's a pleasure, Tsegofatso. Good, Pinga. Try to also understand when you got a specific question wrong, and you'll start noticing patterns. Yes, absolutely, Tsegofatso. How are we going to do question 2.6? What do you guys think we need to do here for question 2.6? Distance formula. Good, Chad. Absolutely. So we're subbing into distance formula. Yes, it would, Mosey. Good. Yes, layer 2, sub into distance formula. Okay, so what I'm going to do then is I'm just going to move that down just a little bit, and I'm going to sub into distance formula. So I'm just putting it on the screen at the moment. There's our change in our x coordinates, our change in our y coordinates, and sorry, my length of my line, GC, is root 17. So that's got to go over here. Okay, now it comes to me subbing in. Yes, Pinga, you are eventually going to end up solving simultaneously. So now I've got to pick an x coordinate. Okay, so the x coordinate at G is S. So if I decide to work with the letter S, then my x coordinate at C is -3. So this will be S plus 3 squared. Now I want to work with my y coordinates. What am I going to write my y coordinate as? Exactly, Tsegofatso. What T is equal to. So it's equal to 2S plus 1. That's it. So instead of writing T minus 4, Pinga, I could do that, but I'm going to rewrite T as 2S minus 1 plus 4. Does that make sense? I'll just go back up here. Remember, they told us that T is equal to 2S minus 1. So I'm subbing in the place of that T over there. Okay, you could have done it in the next line, Penga. I just did it in the first line. Is everybody happy with that? Does that make sense to everybody why I've chosen to do that? So T is equal to 2S plus 1. So essentially my Y coordinate at G is 2S minus 1. That's why I've subbed it in. Okay, so the 4 is the Y coordinate at C. Okay, so sorry, I know it's a bit difficult for you because you don't have the questions in front of you. And I've obviously seen the questions, so I know where the things come from. Okay, does that make sense? Oh, okay. All right, cool. Okay, so now what do I need to do to both sides? What am I going to do to both sides of my equation, Matrix? Square. Good, Mosey. Well done. You're on the ball. All right, so I'm going to square the left-hand side and I'm going to square the right-hand side to get rid of these horrible radicals. These horrible roots, don't want to work with them. Okay, so on the, oh, why do I keep doing that tonight? Okay, so on the left-hand side, we have 17. And on the right-hand side, we've got s, which looks like a 5, plus 3 squared, plus 2s, and I'm just going to simplify a little bit here, minus 1 plus 4 will leave me with plus 3 squared. Okay, so some p-ware. Let's just go back up here again. Okay, they've told you that t was equal to 2s plus 1. It's what I've highlighted here in pink. So because I can't solve for two different variables in the same equation, I'm writing t, my y coordinate at g, in terms of s. Okay, so when I subbed in over here, this is my y coordinate at t, 2s minus 1. Oh, sorry, it's supposed to be plus. Sorry, guys. Plus 1. Sorry, that would change this. Then my answer would be correct. Sorry, so that would be a 5. Okay, so my y coordinate at g is t. T is equal to 2s plus 1. So when I sub into distance formula, I'm replacing t with its equivalent in terms of s, so that I'm solving for s in my equation. Remember, I can't solve for two different variables. So essentially what they've done here is they've given you the one equation. They've given you the t equals 2s plus 1. The other formula that we're using is distance formula, and we're solving simultaneously. Does that make sense? Is everybody happy with that? Zwanaka.
Hello, ma'am.
Hello, Zwanaka.
Uh, uh, Ma'am, I think I missed the parts where you said, where exactly is the 2s coming from again?
Okay, so we were given that. We were given that, Zwanaka. So up here, they told us that t is equal to 2s plus 1
Oh,
in question 2.6.
okay.
So, so
Yeah.
okay, so what I'm doing is I'm saying my coordinates at G are now S and 2S plus 1. Those are my coordinates at G. And then I'm subbing into distance formula using my coordinates in terms of S.
Okay, thank you, ma'am.
Okay, it's a pleasure, no problem. Okay, so that's really the hard part, I suppose. The rest of it is all just our usual mathematics where we need to square binomials, etc., etc. So this would give us s squared plus 6s plus 9. And then over here, this would give us 4s squared plus 20s plus 25. And now we want to get it into standard form. So that would be 0 on this side. We'd have s squared plus 4s squared would give us 5s squared. We've got 26s. And then we've got, sorry, I've just realized I've made a mistake. Sorry, guys. This over here, sorry. This over here should be a minus. Sorry, because 4 is a positive. Do you see that? So it should be 2s plus 1 minus 4, not plus 4. Sorry, let's just correct this. Sorry, I realized now that I'd made a little mistake there. Okay, so this should be minus 3, like I think I originally had that. Anyway, all right, so now that gives us 4s squared minus 12s plus 9. So no, Chad, that's just the letters they chose to work with. So T and S in this case. Okay, so they're forcing you to work in terms of S. All right, which is not great. Working with an S is not great because it looks like a 5, but anyway, there we go. Okay, so now what do we have? Let's just get back here. Okay, so we've got 5s squared. Then we have got 6 minus 12, which would be negative 6s. And then we've got 9 plus 9 minus 17. So that would be 18. So that would be plus 1 over here. All right, and now that should factorize nicely, or if we don't want to use factorizing, we can use the quadratic formula. Our factors, so we would have 5s over here and 1s over there, and we'd have to have 1 and 1, and because we've got a negative in the middle and a positive at the end, it would have to be minus. So let's just check that works. So that's 5s squared minus 5s minus 1s is our minus 6x, plus our 1, so that's fine. So now s is either equal to 1 over 5 or s is equal to 1. And now we've got to go back and go and sub into that other equation and work out the corresponding values of t. Okay, so t is equal to 2s plus 1. So that would leave us with I'm getting 7 over 5. So 2 different solutions for S and 2 different solutions for T. That's it, Mary Lynn, I got the same answer. Okay. How's everybody feeling about this particular question? Is that making sense to everyone? Yeah, that is complicated, isn't it? Okay, but I mean, these are the sorts of solutions they're going to expect us to be able to do. No, so you can't, this has to be done algebraically. There's no other way of doing it. Okay, especially for something that's 6 marks. Yeah, Chad, don't do that. Don't change letters. Yeah, I understand why you would want to do that, but rather don't. Okay, it's unfortunate that they've used an S in this case. I agree, but yeah, don't do that. Don't change it and then go and change it back later. Rather just work with what you've been given. Okay, so subbing into distance formula, standard form, our factors, our solutions for S, our solutions for T. 1, 2, 3, 4, 5. I wonder where our other, maybe there would be a mark here for squaring both sides as well. Because Simpiwe, sorry, it's difficult for you guys because, you know, you haven't got the questions right in front of you. We're using distance formula Simpiwe because they told us the length of GC. Do you see that now when you look at question 2.6 again? Okay, they told you that the length of GC is root 17. Okay, so because they gave you the length of GC, this is a question where we've been given the length of a line. It's also a simultaneous equation. So we would sub into distance formula. Does that make sense? Cool. Yes, so that's what you would need to do. Okay. All right. So now that we have finished off that question, let's go back and have a look at something else. I don't think we'll be able to finish this entire question by the time the lesson ends, but let's get started anyway. All right. What I think I'm going to do here is give you guys a bit more opportunity. Rather than me do the question, what I'd like you to do is do a question, send me an answer. So you can either send it to Yolanda and I, and then we can confirm that you are on the right track. Okay, so let's start with 2.1. You're going to calculate the length of BE, and then please just DM either Yolanda or I, so that if people are not at the same speed as you, they're not, what's the word? Sort
You
of put
won't
off
feel
by the fact that you're putting
pressurized.
answers. Yeah, they don't feel pressurized. Exactly. Exactly. Well put, Yolanda. Thank you. Discouraged. Yes, that's a good word. Thank you, Chad.
Ma'am,
Yes.
2.3, I can't see is it says parallel
Oh,
to B
sorry.
passing
Yeah.
through.
Passing through C.
Sure, thank you.
No problem. Good. Well done. Okay, Mary Lynn, Letu. Lovely. Good. Good, Boycho. Yes. Good, Mary Lynn. Well done. Good, Swanaka. Good, Simpiwe. Good, Mbali. Good, Boycho. Perfect. Good, you guys all sending through correct answers. That's great. Yes, Tegofatso, that's correct. Mary Lynn, I'm just going to double check. Okay, it's all right. That's fine, Marilyn. I got a different C value from you, so that's fine. Yes, Letu, that's perfect. Good. That's cool, Marilyn. At least you realize your mistakes. You know what I mean? And then it means that you can go and you can correct the things that you've done wrong. Okay, because I mean, you've got to be able to do that now in your final exams. Okay, no problem. Swanaka, that's perfect. Mbali, perfect. Good. Yes, Marilyn, that's lovely. That's perfect. Tsegofatso, I got a different C value to you for question 2.3. So the sorry, yes, the y-intercept of your line, I got something different. I didn't get -1/4. So just go and check your calculating there again. Boycho also got a slightly different answer to you. Oh, it's also your C value that's different. Almost. That's it, Boycho. That's right. But it needs to be negative, hey? Yes, Trish. Yes, yes, yes. All of that's perfect. Okay, good, Trish. First 3 questions are fine. Boycho, same answer, but it needs to be negative. Yes, Simpiwe, that's the answer I got. Well done. That's perfect. Mary Lynn, let's just go and have a look by 2.4. What x are they talking about isn't in the equation? Okay, so the x that they are referring to show that x is equal to -4 is the x at A, Mary Lynn. Okay, the x at A. Right, it's up here as well, and then it's also on the diagram. Okay. Good, Tsegofatso. Good, Bonga. Lovely. Zwanaka, I see I see you must have done something similar to, I think it was Tsegofatso. Your C value is incorrect, Zwanaka. So just go back and double check that. It's not supposed to be -1/4. That's it, Bonga. Good, 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 good. Perfect. Yes, Bonga, that's perfect. Well done, guys. Okay, so Mbali, let's just do that with you quickly because I see you've got the answer incorrect there. All right, I mean, my answer was fine, but I'm just going to show you. Okay, so Mbali, you've got in question 2.3, the line is parallel to BE and the gradient of line BE is 1/4, right? So you've got y equals 1/4x plus c, and then you are going to sub in point C, which has the coordinates -2 and -5. So -5 is going to go over here. 1/4 is going to be multiplied by -2, and you've got to work out the size of C. All right, so when you say 1/4 times 1/4 times -2, you get a -1/2. Maybe I should just write that down on the page. So you've got -5, -1/2 plus c. So now you've got to take that -1/2 over to the other side. Okay, so that's -4.5 or -9/2. Okay, Mbali. So this is y equals 1/4x minus 9/2. That's it, Pinga, correct? Yes. I got a different answer for 2.7, Pinga. We out just by a little bit. I wish I could see what method you'd used. Yes, that's correct, Boycho. Good, well done. That's your answer for question 2.6. Good stuff. Yeah, with pleasure. All right, so question 2.6, calculating the size of angle theta. So here, Voloshin, sorry, my silly pen's doing this again. Here, Voloshin, we need the gradient of this line. Okay, so we need the gradient of line AEC. So you have shown that the x coordinate at A is equal to -4 from working backwards from the midpoint formula. So that means that the gradient of line AC is going to be 3 plus 5 over -4 plus 2. So that gives you 8 over -2. So the gradient of that line is -4. So now we're going to use tan theta equals m, -4. Because the gradient of the line is negative Voloshin, you first got to calculate a reference angle, okay, or a PAA or a key angle. So your reference angle or PAA is going to be equal to, so you go shift tan, put in the 4. Your reference angle is 75,96. And then to get theta, you'd have to say 180 minus that. All right, and that's where the others are getting the answer 104,04 from. Okay. That's it, Swanaka. Perfect. Well done. Good, Mary Lynn. You've got that answer. Okay, good, everybody. I also just want to emphasize when you do question 2.5, just be careful again in terms of your setting out when it says show by calculation that AC is perpendicular to BE. Okay, we need the gradients of both of those lines. So you've already calculated the gradient of BE in 1.4. So in 2.5, you've got the gradient of BE, it's 1/4. In a separate calculation, okay, well, I suppose actually then this over here, sorry, this is what happens when you do questions later that you shouldn't have done. This actually belongs to 2.5. So this should have been done over here. So I would have calculated the gradient of line AC, and I would have got -4. And then what you're supposed to do is say 1/4 times -4 equals -1. So that means that the gradient of BE times the gradient of AC equals -1. Therefore, BE is perpendicular to AC. You do not write this first. Okay, a lot of students make the mistake, and that's the first thing that they write on the page. That's what you're trying to prove. Okay, it's not what you must start by writing. All right, so in 2.7, calculating the area of triangle FBE, we're going to go a little bit over our lesson, but let me just do this with you. This is the way, yes, numbers before the letters, quite right, Zechofatso. This is how I think I would answer this question. You could use the area rule as well. But I think that I would probably stay away from that and rather just do half base times height. Okay. That being said, you know, you don't have to. You can use the area rule if you want to, but then it means you need to know the size of angle alpha as well. No, that's not what I got, Pinga. I got 2,25. Okay, but I'm going to show you now. I'm going to quickly do the calculation. All right. So if I treat line FB as my base, I can work with a perpendicular height over here. All right. So they've given me the coordinates -3 and -1. So remember, your x coordinate tells you how far the point is from the y-axis. The y-coordinate tells you how far the point is from the x-axis. So in other words, the length, this little line that I've drawn in here, that perpendicular, is going to be 1 unit. So what I need is the length of is FB. What I'm going to do here, just to clear a bit of space here, in order to calculate the length of FB, I need to know the coordinates at F. So line AC has got a gradient of -4, doesn't it? So the equation of line AC, the gradient of AC is -4. So the equation of line AC, it'll be the line y equals -4x plus c, and then I need to sub in a point to work out the value of my y-intercept. So let's say I decide to sub in point A. I would say that 3 is equal to -4 into -4 plus c. So that would give me 16, and 3 minus 16 would leave me with 3 minus 16 leaves me with -13. Okay, so that means that the equation of line AC, it's the line y equals -4x minus 13. So if I want the coordinates at F, the x-intercept, then I would let y be equal to 0. So that means that 13 would be equal to -4x. So x would be equal to -13/4. So now when I calculate the length of FB, it is a horizontal line. So FB is going to be the x-coordinate at the right minus the x-coordinate at the left. So that means FB is 4,25 units. All right, so now the area of triangle FBE is equal to half base 4,25 times perpendicular height. Okay, so there we go. That's it. So it's 2,125 units squared. Okay, so this was question 2.7. Oopsie, we've really gone quite a lot over this evening. Does that make sense? Otherwise, you'd have to use the area rule, which I think trying to work out the size of angle theta and okay. Tsegofatso, any coordinate on the Cartesian plane. So let's take C for example. The coordinates here are -2 and -5. So the point C is it's 2 units in this direction from the y-axis, and it's 5 units from the x-axis, isn't it? So if you were to actually measure the length of this line would be 2 units long, that line would be 5 units long. Okay, so from here, there, that line is 3 units long, this line is 1 unit long. Oh, yes, then it was correct. Sorry, Penga. Yes. Sorry. You were quite right.